I welcome all the participants of Atal-sponsored 5 days FDP on perspectives of blockchain integrated IoT, challenges and opportunities. And I extend my warm welcome to the CEO Arunjit Chaudhary sir, and he is providing assistance in teaching students in latest trends in information technology aligned to industry needs. And he is having a rich experience of 25 plus years working in IT industry for Tier 1 clients across US, Europe, and Asia Pacific. And he is certified in sales and distribution module with SAP and certified Scrum Master from Scrum Alliance. He has passion for teaching and have taught students across 14 colleges in Mumbai in area of SAP and machine learning. And regarding his professional experience, he is in CEO EBTS from February 2014, and he is having a vast experience of around 20 years handling different technology projects across Asia, Pacific, USA, and Europe. He's worked in different capacities as a project manager, quality manager, program manager, and key delivery manager. He's also worked across various industries in manufacturing, defense, banking, and CPG. And when looking after his training highlights, he has trained students across 40 colleges in latest IT trends, and he is having excellent testimonials from different students. Next, I would like to extend my warm welcome to our resource person today, Mr. Pranav Bharatwaj. Mr. Pranav Bharatwaj has delivered 40 plus training sessions on blockchain development and blockchain architecture for close around 700 participants, domestic and internationally, coming from different backgrounds. And when regarding his certifications, he has received certifications in blockchain development, Red Hat certified engineering, and he has also received certifications from Train the Trainer certification. And looking after his experience, he is having 8 years of experience in web application building and telecom industry. He is having 4 plus years in blockchain development, having developed applications for insurance, healthcare, and logistic domain. And looking after his role, we are very much happy to see that he is an excellent blockchain trainer and architect, leading a team of developers and imparting trainings globally across various domains and platforms. And his training have imparted multiple trainings and hosted workshops for expanding the knowledge base of blockchain and focusing on how the same can be leveraged in the industry. And he is having a motto that always start with an aim, strengthening the base. I welcome both the persons to our FDP. The session is yours, sir.
Yeah, Pranav, you can take over.
All right. Thank you so much, sir, for this introduction. I'm glad to be here right now with this group. And it's always fun to have such sessions because they're always meaningful. We always learn a lot. So good morning, everyone. My name is Pranav, as introduced, and we are going to talk about the blockchain challenges with the implementation of IoT. So let me pull up my screen and then we can get started. Please let me know once it's up.
Yes, sir.
Okay. All right, cool. So I just want to have a very interactive session. That's what I aim to have. So feel free to unmute yourself and speak up in between whenever you have any thoughts, comments, or questions. And we would love to take that conversation from there. Now, before starting, I would just like to ask you randomly, all the folks in this group, that what is your understanding of blockchain and IoT together? Maybe you want to take up some use case. Maybe you want to explain it with something that has happened in the past, something that you have developed, something that you have learned about, anything. Does anyone wants to take a stab at it? I know you have had sessions previously. No?
Good morning, sir.
Hello, good morning.
Yeah. So actually, I think the blockchain is it is a missing link between IoT and security.
Mm-hmm.
The blockchain is considered as a missing link between IoT and its security.
Right.
Because most of the IoT devices are vulnerable.
Right.
And blockchain provides us security.
Right. So what is the security that we are talking about? I mean, I'm just trying to understand the depth. That are we talking about the security in terms of identity? Are we talking about security in terms of the data that is being fed? What is the definition of security out here?
The blocks in blockchain are immutable, and integrity is maintained. The data integrity is maintained.
Right. Perfect. Perfect. Thank you so much for this explanation. So yes, blockchain and IoT, when amalgamated together, they deliver you. It acts as a game-changing tool, right? It's evolving the industry. It's getting the revolution that you need in the industry, and across many industries, not just one industry, right? So to start off, why do we call this as a game changer? IoT refers to the concept of extending internet connectivity beyond personal computers and smartphones, basically getting connectivity to your devices. Those devices could be anything, right? Those devices could be from those miniature sensors to maybe big machines. Everything is a device. Doesn't matter what the scale is. And when it comes to blockchain, then blockchain refers to your concept of storing the data in an immutable fashion, which we just got to know as explained, right? Immutable, it cannot be tampered. It cannot be changed. When we talk about blockchains, we have different kinds of blockchains: public, private, permission blockchains. And in permission blockchains, we have a concept of admins as well. But do you think admins in a permission blockchain application like maybe Hyperledger Fabric can go in and change the data, or they can do some manipulations? No. Because what we are trying to build is a completely transparent, trustworthy environment. The only role that admins have got in permission networks is to give read or write permissions, but they don't have any permissions to play with the ledger. So talking about the underlying concept of blockchain, doesn't matter. People do get confused that blockchains have got admins, and we are coming from the traditional world, dealing with the traditional stack, traditional databases, where we used to have admins, and admins have got all the right to go in and manipulate any data, but that's not possible. So combining these two, what do we get? Your internet of devices or your network is storing the data in a trustworthy data store or a trustless environment. Why do we say a trustless environment? Because we don't trust people. We trust devices, we trust machines, we trust automation, we trust code. We don't trust people. And that's the reason we say that this is a trustless environment. Right? Now, I want to start off with a use case that I personally worked upon quite some time back. Now, we all understand, we all have a background of what blockchain is. We all have a background of what IoT is. The devices emitting data, devices sending data. Let's start off with a use case so that we all are at the same level. Now, this use case was to track to track the counterfeit of vaccines, and the aim is to give the security in the hands of the people, okay, with the help of a mobile app. Mobile is something which can actually give the security in the hands of the people. Now, this project wasn't part of my company or anything. This project came in as a part of the hackathon. Now, when we built this solution, the aim of the solution was that every user should be able to scan the vaccine vial before consuming the dose, before consuming the vaccine, right? Though it has not been implemented, there are many solutions around it, but this was a pure example of blockchain and IoT where it acted as a game changer. Let me go back. So let me open up Paint, and so we can draw in something. If I talk about the high-level cycle of vaccines, who do we have in our complete supply manufacturing cycle? We have manufacturers, right? And we have let's say the shipment companies. Then we have the healthcare provider. Okay, we have the healthcare provider. Of course, there would be government nodes, there would be government intervention in between, people would be auditing, but I'll slowly get all of them into the consortium. Now, when vaccines are being treated, almost every manufacturer we have seen that they have set, the minimum and maximum temperature value in which those vaccines should be kept, and that's the threshold values. And we have minimum or maximum humidity values, right? This data has been stored into the ledger, in an immutable ledger, and manufacturer says that, hey, my vaccine should be kept in this temperature. Now, what manufacturer does is that manufacturer takes up, we have different boxes, or we can call them as batches, which are containing different vaccine vials. Now, those vaccine vials, let's say one box has got 100 vials. We place an IoT device on top of each and every vial, right? We place an IoT device on top of each and every vial at the time of manufacturing. Manufacturer sets the temperature in the blockchain and gives it to the shipment company. From here, now your transaction goes here. Now the shipment company, let's say a shipment company is not maintaining the right temperatures or something, but the IoT devices that are kept right on top of each and every box containing 100 vials is continuously emitting data. And where is that data going? The data is going to the shipment company's node. The data is also coming to healthcare providers node, and the data is also coming to the manufacturer node with its updated status that this box, this lot is currently under the possession of the shipment company, and it is getting spoiled. It emits a triggering event. It emits a triggering event that, hey, this vaccine, this box has got spoiled because the temperature went down below, let's say, 20 degrees. The minimum temperature threshold that we have set out here is minimum is 10 and maximum is 15. Now the temperature reached 20 degrees and the vaccines got spoiled. In today's world, we don't have a solution to identify if the vaccines that we are consuming, were they kept properly? Are they okay? Right? Who knows how they have been treated? We don't have an answer. The entire chain, the entire supply chain gets so complicated, and even the healthcare or the medical industry doesn't have an idea that what's happening around us. And especially people taking undue advantage of the pandemic. Everyone is, maybe, somewhere in the world, in developing countries, people are taking empty vaccine or the empty vaccine bottles or the vials, filling them up with water, and then re-injecting the vaccine because everyone wants to take an undue advantage of the pandemic. Who knows? Now, when the status changes, that from the shipment company, vaccines have been delivered to the healthcare provider, we can have an application, a mobile application, maybe let's say launched by ICMR in our country, or by some government organization. Everyone, when we go to take the jab, we can first ask the person that, hey, can I scan my vial? You scan your vial, and it just shows you whether the vaccine is healthy to be consumed. It also shows you if the vaccine is spoiled. Was it spoiled? That means it's unhealthy to be consumed. And it also shows that if this particular vaccine vial has already been consumed, because whenever the healthcare provider is injecting that vial to a person, they are updating the status in the blockchain. So over here, we have the end consumer. We are updating the status in the blockchain that to this Aadhaar number, this particular batch or this particular vial ID has been injected. And that vial ID becomes consumed in the ledger. Its status gets updated in the ledger, in an immutable ledger. Now, this is the value that IoT devices, and bring the real value to the table. That's a value proposition, that how exactly so many, this is just one use case that we are talking about, but there would be many use cases across different industries. The wearables industry right now, Apple watches, Samsung watches, what are they doing? They are all IoT devices. They're all IoT devices. It's just that they are all using different protocols, which comes in as a challenge. I'm going to touch base more on it, but using different protocols for different devices comes in as a challenge. So with this use case, if implemented, we can actually give security in the hands of the people, and we can really avoid any such incidents happening across the globe, right? Before moving ahead, I want to check, do we have any questions, thoughts, comments around this?
No, sir.
All right, cool. So, what do we expect from a good supply chain? We expect an end-to-end visibility. High visibility makes it easier to track consumer market and fix the issues. The supply chain industry globally is something which we cannot actually we cannot mark the length of it with the scale. There is no way out that we can actually check that how expanded it is. We have seen so many different issues around the world. For example, when the pandemic started, there was no toilet paper in the United States. What was that? That was a supply chain fault. We don't have the right systems in place which can immediately check the status, that what's the inventory, when a right purchase order should be raised, and how much in advance. And when we talk about all of this, we need even AI in place. We need artificial intelligence in place so that algorithms can learn from us. Then we need a quick analysis system, an intelligent system that fills the gap. There are so many gaps across industries that, in terms of some device is emitting the data, but let's say another node is not able to read the data, right? And especially if I talk about the functional gaps, then across the supply chain industry, everybody's using different softwares, different portals. We don't know the compatibility of those systems with each other. maybe the misses in the information, the gaps that are being created are because of missing interoperability across systems. Flexibility, that how easily and quickly your supply chain can adapt to changing network map of participants. This world is huge, right? Continuously people are coming in, going out, coming in, going out. Devices coming in, going out. But are we able to adjust to that? How quickly are we able to adjust to that? If my system is raising, let's say, regular orders, every day I raise a particular order, and someday some person moves out. Do I have a backup plan for that? How quickly I can get in a new person, or also a new device which may be intercepting data in a different structure, in a different data structure altogether. When we deal with devices, structuring the data is really important. Different data structures can lead to those missing linkages. And I really compare people with devices, right? Because for us, devices play the same role as people does. We are trying to build that intelligence in devices, that what people are capable of doing, that's what our systems should be capable of doing. Trust is the most important thing for having channelized operations. Now, one is trusting the participants. Another trust is trusting the devices that are surrounding you. Right? How do we have that trust? We need to have that trust in the supply chain. And we are talking about supply chain industry right now, but that's valid across all. If I talk about healthcare industry, if I talk about wearables industry, everyone's having, those smart watches today. We are trusting the data that those smart watches are providing, right? We are trusting. That's the reason we are shelling out money. So trust is one factor which should be everywhere. And with blockchains, we are trying to build a trustless environment where we put our trust more on devices than on people. Reliability on data. Now, trust on data that is being fed to the system. Your blockchains are immutable, right? Blockchains are secured by hashes. Blockchains are, the data is secured in the form of blocks. Every block has got a previous block hash. Every block has got a Merkle root. And they're so tightly coupled that we achieve immutability, because if someone has to change anything, I don't know, the entire ledger can go corrupt, because some person to make a change in the transaction, I don't know, will have to manipulate how many hashes. But who knows, who takes the guarantee that the data that is being fed to the blockchain is right? Your blockchain, your smart contracts can take decisions based on the data that is being fed. But who knows what data is being fed? For example, if today you go to a pharmacy and you go in and say that, hey, I want to buy this medicine or any tube, cream, anything. If that is spoiled, what do? You go back to the pharmacy, say, hey, this is spoiled. And the pharmacy guy has no idea that maybe, from where that tube actually came from. The provenance of that product is missing because we don't have any supply chain model. the provenance of that product is missing, that who was actually at fault, who was the originator, who was at fault for the reason that why that cream, why that medicine got spoiled. Who nobody knows that, nobody can answer that. Now let's say that to manufacture some medicines, we have people in the manufacturing plants, right? They are setting the computers to the right temperature values that, okay, if we want to manufacture paracetamol, then it needs to be manufactured between 2 degrees to 5 degrees. A person can go in there and by mistake, he can set the temperature from 5 to 9. Maybe it's a mistake. It's not a, intentional fault. It's a mistake. But now, to cover up that mistake, that person is going to still feed in the data that I have manufactured paracetamol between 2 degrees to 5 degrees. He's not going to say that I have manufactured it at 5 to 9. That's where whatever your blockchain can take decision, but on the basis of the incoming data payload. If the incoming payload is wrong, then you cannot trust it. So a lone blockchain cannot bring a reform to this industry. When we have IoT devices out there and those IoT devices are emitting data to the blockchain, we know that there is no manual intervention in the entire system and the devices are emitting the data. That's when we bridge the gap. That's when we fill in the gap. Right? So reliability on data is of utmost importance because your blockchains can listen only to what is being fed. Restricted access. Right people should have the right access. In a supply chain, we just can't give access to anyone, right? Playing with the data. So we need to have authorized users in any model, in any supply chain model. Now, these are the few factors that we think that are apt for a good supply chain. So, talking about the key industrial applications and where do we actually see different kinds of challenges. Supply chain we have discussed, right, across. And supply chain, if I talk about especially the industry that's benefiting from blockchain and IoT together, this amalgamation, this combination is the food industry, the drug industry, and recently I heard of one use case in the oil industry. Now, let me share that with you. When ships are moving from across continents carrying oil, let's say, there is a lot of manipulation of data because nobody knows that which route the ship is going to take. Okay, so the calculation of the transportation cost for those oil barrels that is being done is a rough estimate. And you know what it happens when something is a rough estimate. 90% of the time, the estimate goes above and beyond. How about fitting IoT devices which are continuously tracking the data of your oil barrels, and those IoT devices are emitting the data which is being captured, the geographic location, latitude, longitude, and those geographic locations are being fed to the blockchain, to the smart contracts. The rate is fed to the smart contracts, and your smart contracts perform the calculation that what's the estimated amount for this particular shipment. We don't ask people telling us that, hey, you know, today the weather was bad, that's why we took a longer route. And generally it would be a longer route. This is pure business. So that's where the transportation industry can benefit, when we are able to track our goods in real time. The food and the drug industry, of course, you know, we have a lot of role of temperature and humidity across these two industries in their supply chain, and we really need we really need to understand that how things like milk is handled. There's so many shipments happening, how different drugs are handled, because medicines are supposed to be kept at different temperatures, different humidity, and that's where blockchain IoT comes to rescue. Home automation. One of these security, so initially when we started up this discussion, we understood that IoT devices are vulnerable. And we were looking for the definition of security, which was very well explained. Another thing, if I go back to the same definition, what security could be additional? Let's say you have got devices outside your home, okay? And what we are checking with the help of those devices is that who is actually entering, which means what we are checking is the identity of the person, that is the right person trying to access this device. Devices are vulnerable and they can be manipulated. If you put in some mechanism, let's say of fingerprint identification inside the device validates and tells you. But at the end of the day, your device is kept placed outside your home. You cannot have an identity verification done from within the device. You cannot bring in that intelligence, but you can have that identity validation done from the blockchain. This is the combination of getting decentralized identity with IoT. So a person goes in, you put in your fingerprint, your biometric, the API call goes to the blockchain, which fetches the data from the ledger and then tells the device that, hey, this is what you have to say. You know, different door handles right now, what we have across our homes, across hotels. The identification mechanism is inbuilt, is in those devices. They're not querying the data from anywhere. And we record that how many times a person has actually got into the home, who has tried to access via blockchain and IoT. There's so many smart devices in your home. Wastewater management. There's so many industries, right? And water is something that we use everywhere. Okay? Water is something that we use everywhere. And we don't know that how much water is being wasted every day across different industries, different factories, different plants. What if we deploy IoT devices across different water resources, which start emitting the data that if there is a water leakage, and brings up a notification to the security office, to the admin's office, that, hey, at this portion of the plant, you have water leakage, or someone has just opened the tap and gone to sleep. we can actually save a lot of water around this. I'm unable to recall the numbers, but the numbers are pretty high, that based on how much water we can save by implementing these devices across your plants. They are continuously emitting data. I don't know how much data they will be emitting. The question comes, can blockchain handle that data? We'll come to that. Smart health or wearables. The wearables that we are having today, these are nothing but IoT devices, right? They are capturing when you go out for a jog, they capture the humidity, temperature, your location, when you are going for a run, are you doing cycling? They're continuously emitting the data. So many devices save so many lives. These are all IT applications. But do you have connectivity every time across the country? These devices, are they always connected? Are they missing out connectivity at any point of time? Are your devices also working when you switch continents? Do you have that infrastructure ready? That every time, every second, these devices are taking care of you? We need to work on that. We really need to work on that. With the advancement of LTE, 5G coming and playing its role, a lot of work has been done, but still a lot of work needs to be done. Right? Healthcare industry. How do different providers save or store different vaccines, different injections, different vials? Do we have any monitoring around it? Can we actually calculate the waste, or can we actually calculate the fraudulent fraudulent injections that are being fed to the people? Why aren't I saying that it's fraudulent? Because if something has expired and you have injected it to someone, that will be called fraudulent. Nobody checks it till date. We are only working on trust. Trust is the only thing on which we are working right now, nothing more than that. Right? So we need to bring in that reform where we move away from trust. We build a trustless environment. Manufacturing and storage units. Manufacturing could be anywhere, in terms of food, in terms of drugs, for example, one of the use cases that we discussed. And storage units, especially cold storage units, where we keep the produce for a pretty long time, and we don't have any monitoring around it. So the sole role that IoT is playing over here or across these industries would be monitoring. And why? Because we want to ensure that correct data is being fed to the ledger. So, do we have any questions, thoughts, comments, or maybe someone wants to share something? We'll be glad to listen to you. I mean, whatever you have to share, or you have a point to make.
Excuse me.
Yeah, please go ahead.
So if there is some error in the data that is already entered, and if I want to correct it, then how will it possible? I have to make a new entry of the differential amount, or because I can't go back to the old data, the hash function will change. So in that scenario, what will be the approach?
So in that scenario, your approach would be, let's say, it can be by mistake or it can be intentional as well. So if your data is, for example, you have a registration number of a car as 1234, then you have the type of the car as type is car, and let's say make is Honda, and this is your piece of data. Now you have entered this data into the blockchain, and blockchains are immutable, and a hash has been calculated for this data. Now, by mistake, this wasn't Honda, this was some other company, and you want to make a rectification. In that case, what you are going to do, you are going to make another transaction on top of the previous transaction and make this as Hyundai. Doesn't matter, they let the hash change. Hashes are meant to change. But every time your blockchains are only insert only databases. They don't have those CRUD create, replace, update, delete operations so that you can go in and make an amendment. Now, the data that is being stored in the ledger is always stored in the form of a key value pair. Okay, how do you store data in the ledger? We need to have a unique identifying key with a value into the database, into the ledger. Let's say whenever you are making some entry, your registration number is 1234, right? You know that this registration number is going to be unique, or maybe this registration number could be a chassis number, which would never change, right? Now, this registration number is going to act as your key. And what would be your value? Your value would be this payload data. Now, when you query the ledger from this particular key, it is going to fetch all the transactions that you have made. Let's say you made this transaction on 24th January 2021. Then you made this transaction on 26th January 2021. When you fetch the history of this particular key from the ledger, it is going to fetch both of these transactions in a time-stamped manner. And hence you have the access to the history. So the only way to make an amendment is to make a transaction on top of the previous one. Does that make sense?
Yes, sir. Thank you very much.
All right, perfect. Any more questions, thoughts, comments? Anything related to blockchain, to IoT that's tickling in your mind? No? Okay, cool. So these are the key industries. Of course, we have a lot of concepts around smart industries, smart cities, right? Where automatically the lights of the city, they should go on. We should have devices to know that in what areas street lights are now off, and automatically the team should be sent there. Right now, we send people to go and check that in what areas we have, we don't have lights available, or the lights have gone faulty. So all of these concepts bring in smart city. Dubai is actually one of the first cities to adapt blockchain so quickly that they plan to become the smartest city in 2020, but I think because of COVID, the plan got postponed, and really soon Dubai is going to be the first pure smart city in the world, enabled by blockchain and IoT. And plus, in fact, even AI. Now we have so many different gaps, right? We have so many different gaps across industries, across different industries. What are your thought of? We need to give the advantage to which technology? different features that helps us fill different gaps, we need to give that advantage to different technologies. Auditability, of course, blockchain, right? Everything gets stored in an immutable fashion, and you can query at any point of time to figure out that what needs to be done. You fetch the complete history from the ledger. Transparency. IoT and blockchain both. If, let's say, we don't have any security hacks for our devices, let's say the devices are not getting hacked at any point of time, then your IoT devices are completely transparent. And plus, your blockchain has always been transparent. Blockchain has always been for the people. So devices emit data in a transparent fashion, whatever the condition is. And your blockchain can store that data in a transparent fashion. Real-time tracking, location, geographic coordinates can be done only by IoT. Blockchain is a data store. It cannot track devices. You can track the history of all the transactions, but it cannot track what's happening around the world. IoT can do that. Real-time tracking of the environmental conditions that we had been discussing. What's the temperature outside? What's the humidity? What's the wind speed around? All of this can be calculated by IoT devices. Imaging. When we talk about smart homes, we want to see that who actually entered your home, who tried to access at what point of time, or there would be many industries where we would require IoT devices to capture images and emit those images. Now, when we talk about imaging industry, there is a big challenge with blockchain. Do you think blockchains can store images? It can, right? Yes? No? Any questions, thoughts around this? Can blockchains store images?
I think they can.
Okay, they can. Any other opinion? No? Okay. So when we talk about can blockchain store heavy data, they are not capable of storing heavy data right now. Okay, they are not capable. If we talk about Ethereum, if we talk about Hyperledger Fabric, the blockchain platforms that have scaled really well, they cannot store data right now. And we need a third platform to store data in a decentralized way. Now, this is your IoT device. Okay, this is your blockchain node. And this is what? IPFS or Big Chain DB. Your blockchains still have that scale, that issue that it cannot store heavy files. Even if you make them store heavy files, you will see a big performance lag. Why? Because all of these ledgers are not that mature to an extent that they can perform transactions something like Visa or MasterCard. They cannot store heavy data. We need to figure out ways to store heavy data and how it can be done. How do you set up that integration? Because this is challenging.
Can it store a link to a particular file? The picture may not be.
Yes, exactly. You're hitting the right point. Now, what do we store? Your IoT emits the data, takes the image, and sends the transaction payload to the blockchain node. Okay? Now, when your IoT sends the data to the blockchain node, your blockchain node, we need to have a certain API layer over here. Okay? We need to have this API layer, without which we cannot build this integration. We cannot solve this problem. What this API layer will do, it will fragment your transaction into two pieces. It will fragment your transaction into two pieces, right? What will go to the blockchain, say, let's say time, ID, okay, the biometric fingerprint, then ID, let's say some value, then hash of the image. So at this API layer, we are going to produce the hash of that image. Okay. Plus, let's say we store the URL of the image, and this URL would be like http /IPFS dot something. Now this transaction has gone and has been stored into the database. The hash of the image will be used as a tool to check data integrity. And from this API layer, when the transaction went to the blockchain, the image went to this place. The way you have cloud storages, similarly, IPFS is a decentralized storage of the blockchain world. It stands for Interplanetary File System. And similarly, we have Big Chain DB. You can store these images in a Google Drive as well. You can store these images on some cloud service as well. But your IPFS is a decentralized storage. When you aim to build decentralized systems, you don't want a centralized component in between. So your IPFS works something similar to like the way MongoDB works or the GridFS system works. It breaks the file into pieces, into chunks, and pushes them randomly into the network. Whenever you make an API call to fetch the data, okay, someone is making an API call to fetch the data, at that point of time, the call will also go to the blockchain node. The blockchain node is going to return you the hash value over there. So this is the same API layer that I'm talking about. We have an API layer over here, which is the calling API. And we perform a validation if the image that we have received from the distributed web matches the hash that was stored in the blockchain, which in return tells us that this is the right person. This is the right image. Because you cannot store images, videos directly on top of blockchain. There is a constraint right now. Maybe the technology matures further. We get to see, a lot of work happening over here, but this is the current state. So we need to build separate integration layers in order to deal with the data. Do we have any questions, thoughts, comments around this?
So please, can you repeat the last thing what you said about we are storing the transaction in a blockchain node. After that,
Yes.
you mentioned that we need a separate. Sir, I missed that. We need a separate for verifying. We need separate what?
Okay, so when we store the transaction in the blockchain node, we need an API interface which is going to communicate with the blockchain node and with the file system service where we have actually stored the file. So a validation mechanism needs to be built which would actually match the hashes with the image again. So if, let's say, let me explain this to you with an example. Today, if you upload some MP3 file to Google Drive, okay, and let's say you forgot it, you don't have trust on Google, and 10 years down the line, you want to check, is your MP3 file the same or is it edited? Right? How will you do that? Just listening to the music, maybe you will think that, hey, this is the same file. But what if some data has changed in that file? The closest and the most and the highest proximity way around this would be that you download the file again, and when you would have uploaded the file, you would have secured a hash somewhere. When you download the file again after 10 years, what do? You hash the file again and you try to match the hashes, what you had 10 years ago. If the hashes are same, that means your data is intact. So similarly, when we deal with distributed systems, we need to build an interface, a common interface, which would do this matching for us. It would be a separate API, which was going to make multiple calls to different to this system, and do the matching for the data that is there in your blockchain node and that is actually coming from your file system, from cloud storage. If all of this would have been stored in the blockchain node, this would not have been a problem. This is something that you would have not required.
And is the validation mechanism built on the top of the blockchain?
This validation mechanism would be outside the blockchain. You are fetching data from the blockchain. You are fetching the hash value from the blockchain to validate. But the actual matching is done outside the blockchain when you are fetching the information. You can build this validation mechanism on blockchain as well via the smart contract, but then the data that your IPFS that you are fetching from here, from this point, okay? The data that you are fetching from here, the data will then be fed. So, okay, I don't want to make it clumsy. That's your IPFS node. That's your blockchain node. That's your IoT device out here. Now, when you make a call over here from this IPFS node, your data will be fed to the blockchain smart contract. Your smart contract, let's say this is your smart contract over here, and this is your ledger. Okay, this is your ledger, and this is your smart contract. Now, when you get the data from IPFS, your smart contract fetches the data from the ledger. Okay, the data is returned here. Your smart contract performs a validation and gives you the output. But again, you need to have a compatibility. If not a separate server over here, you need to have some server running on top of the blockchain node. That will be your decision. But there has to be some server which will be routing your request to different mechanisms. This is one way of doing it, that you feed it directly to the smart contract. Another way of doing it would be that you get your data here to this server. Similarly, you fetch your data from the smart contract and you perform the validation over here on this separate server, if not the smart contract. So they're both of the ways are possible. But again, that would depend that what kind of blockchain node are you working with, what kind of blockchain are you working with, and how exactly it can be integrated. It can be done at the smart contract level. It can be done outside the smart contract as well. And once the validation is done outside the smart contract, you feed in the final result back to the smart contract. Does that make sense? I know this is a bit clumsy. I mean, I'm happy to repeat it again if something is unclear. But please be.
Yes, sir. Yes, sir. Thank you, sir. Thank you.
All right, cool. Do we have any other questions, thoughts, comments around this? All right.
Sir, sorry,
Yeah.
one more question,
Please,
sir.
go ahead.
Sir, from the implementation perspective, how we can approach this if we want to integrate this blockchain and IoT? What tools and techniques should we begin with? From what tools and techniques? Like, should we go directly for the open source blockchains like we have Ethereum, etc., or should we go from hardware perspective? Sir, any suggestions on that?
So, I mean, most of the blockchains are open source. There are hardly any blockchains which are, for which you need to pay for. In fact, when you work for building these networks, the major decision comes in that one, do you want to use a public blockchain or do you want to build a permission blockchain? For industries, for industrial applications like supply chain, for any of the enterprise applications, you need to have a permissioned blockchain, and Ethereum will not suffice in that case. You need a blockchain like Hyperledger Fabric. You need a distributed ledger like Corda in that case to build those solutions. Now, Ethereum, if you build something, you will face a lot of scalability issues with Ethereum, right? Because IoT devices emit a lot of data. IoT devices emit a lot of data, and that data, how will Ethereum respond to that? You need a highly scalable system. I'm going to touch base more on this right now, but to your answer, the IoT devices that you have, so we have limited options for IoT devices based on different protocols. In terms of choosing a blockchain network network's decision is always taken based on the use case. Always. Your blockchain network decision will never be taken based on what kind of infrastructure you have, what kind of devices you use, because that is your major decision. That is your database. That is something that controls everything. So always your use case is going to decide that what blockchain network you need. Okay. In terms of, for example, the supply chain industry, the healthcare industry that we talked about, especially, if you have royalty management, reconciliation, net settlements done on top of blockchains, then you need to have a permission blockchain platform in most of the cases. A permissioned private blockchain platform and not a public blockchain platform in that case. So that being said, that your decision on blockchain depends on of this connection. The first decision would be here, that what blockchain platform you use, and that will totally be derived from the use case, right? Everything starts from there. Everything. Every use case might not be a blockchain use case. Maybe you don't need blockchain at all. Blockchain is not a golden bullet that can solve every problem in this world. No, it cannot. Let's be very honest about it. Just for using some upcoming technology, we can never push. We can never make a deliberate push that no, we have to use it. No, maybe it's not required. Maybe you can still serve with decentralized databases. So apart from that, if you require a blockchain, I would say in most of the networks, you need permission blockchains like Hyperledger Fabric. Ethereum can also come to use, but looking at the challenges that we have between blockchain and IoT, it will be a strategic decision based on, and question number one would be, how much data is going to be pushed? Okay. Question number two would be, how many transactions per minute or per second, whichever, whatever your scale is. Your question number three would be, what kind of data is going to flow in? Your question number four would be, do I need permissioning? These are the four high-level questions in order to understand and narrow down the road for us to decide a blockchain platform. How much data are you going to push? Are you going to deal in GBs? Are you going to deal in MBs? What is your transaction volume? Because every blockchain cannot cater to every volume. Every blockchain has got its own limitations. How many transactions per minute? Your Ethereum maybe cannot handle more than 500 to 1,000 transactions, not even 500 transactions per second. But when you go to a platform like Corda, you go to a platform like Fabric, you have 5,000 transactions per second, or 4,000, 3,000 transactions per second. So if your use case says, no, I think I'm going to emit one signal every 5 minutes, or I'm going to emit 10 signals every 10 minutes, you can go for something like Ethereum. But again, the conditional would be that, are you willing to pay gas? Are you willing to pay transaction fee? Are you willing to pay gas or transaction fee? What is the role of your network? There's so many questions surrounding this decision-making process. So it starts from use case. This will be your decision based on the use case, but for that decision-making process, we know what the questions we have to ask. And integration with IoT is altogether a different stream. We have limited set of devices with different Arduino boards. We have different, Raspberry Pi controllers. We have different protocols that different devices are using. For example, so many devices are using Zigbee. Some devices use AMQP. Some devices use MQTT. There's so many different protocols that these devices use. We need to check that what kind of emission they do, and that where we are going to decide. But the first primary decision would be to choose the right platform, because once you establish your network, there is no looking back. It would be a waste of money if we have made a wrong decision while choosing a blockchain platform. Maybe this discussion hasn't answered your question in an apt way, because I believe that we don't have a fixed answer for that, as it all starts from a use case. If you try and explain me a use case that this is what I'm looking forward to, we will have a more specific discussion around this. But I hope this makes sense, whatever we have discussed. Does it make sense?
Yes, sir. Yes, sir. So basically, I was thinking about the security issues in IoT and mitigating those issues using blockchain. So I don't have any specific use case till now, sir.
Okay, so the security issues that you're talking about are basically what?
Like DDoS attacks in IoT. They are more common attacks. The most common attacks in IoT, like DOS attacks.
Okay, so to avoid denial of service attacks in the IoT industry, we need to restructure and we need to bring in decentralization to devices, which is missing. Right
Yeah.
now,
Yeah,
right
yeah,
now,
yeah.
right now, how does exactly, if I have to build a diagram, how does it actually work? You have your, okay, so you have your blockchain nodes, okay? And that's your blockchain node. And let's say these are your IoT devices. Sorry, that's a bad figure. These are your different devices, let's say across different geographies. The point is that these devices are right now arranged in this fashion. Okay? These devices are right now arranged and sending data in this fashion. This is the overall structure, that how devices are emitting data. Whereas your blockchain nodes, on the other hand, if you have one blockchain node here, one blockchain node here, one blockchain node here, one blockchain node here, we have achieved decentralization here. This is going to be very messy. Apologies for that. But okay, we have achieved decentralization in this network. So this is your blockchain node. This is your blockchain node. That's your blockchain node. That's your blockchain node. And that's your blockchain node. But we don't have decentralization for IoT devices. What we aim to build is something of this sort. So you have the red ones are your blockchain nodes. Okay. They're all connected with each other. Randomly, we have formed a mesh, and that's how we achieve consensus by random validation of the data, by solving puzzles, and they're different ways. Solving puzzles, something like proof of work, something like proof of stake, proof of importance. We have so many consensus mechanism. Consensus stands for how do nodes achieve consensus, how they are at par. Now, our devices, which are over here, okay, I don't want them in red. The devices which are over here in blue, right? How, instead of these devices talking directly to this interface, how can we have a connection between devices and form a mesh? Let's treat these devices as nodes. Okay, maybe to this extent even. Let these devices try to talk to each other. In that case, we can implement some mathematical functions using which only a single device cannot be hacked. The data communication is not directly via to the blockchain. The data communication, the consensus happens in a random way. We need to have a mesh around devices, which is, of course, not that simple because we always build interfaces, but we need to have a mesh network. The way blockchain nodes achieve consensus for a particular transaction and they try to throw away the bad actors, they try to throw away the malicious actors. Similarly, we need to have a consensus mechanism for IoT devices so that we can throw away malicious actors. We can throw away bad actors. So we form a mesh network and we try to solve the problem in this way. A decentralized layer on top of a decentralized network. Does it make sense? Yep. Okay, so what's challenging? I know with the help of use cases, we had been trying to discuss across many challenges right now. But one of the key challenges is the ever-growing storage requirement. Blockchains doesn't provide you the way to archive the data. When you work with databases, you always have an option to archive the old data, put it somewhere else, and refresh. Make good value, make good use of databases. But you cannot break blockchains into two pieces and place your data somewhere. That means your ledger size will always keep on growing. Your ledger size will always keep on growing, which is a big flaw in the system right now. Hence, we need to be really cautious, and that decision needs to be really appropriate, that what data we store onto the blockchain. We cannot store everything blindly on top of the blockchains. No. Only portion of the data that is relevant to the use case or that is relevant to the problem that we are trying to solve with this application. Only the portion of the data. For example, you have every application has got usernames and passwords. Are you going to store username and passwords on top of blockchain? No. That is something which is not relevant to the other party. That is something that is relevant to you. Why do you have to store it on top of blockchains? So we need to be really cautious till the time we find a fix that how exactly we can archive the old data of the blockchain and then resync it. Till that time, we need to be really cautious when implementing. And with IoT devices, for the use cases that we discussed, they were sounding like really fascinating, right? That we have so much security around the system. We have so much security around, we can trust the data, but the data that those devices are going to emit, let's say every 5 seconds, every 30 seconds, every 1 minute, imagine how much data is going to be consolidated into the blockchain, what the IoT devices are emitting. So there is a big challenge to the system. There is a big challenge to the industry to solve this problem. Blockchain and IoT integration, unstructured data. Structuring the data is really important. Your blockchains can read through the data if it is properly structured. IoT devices, every device emits data in a different way. How can you structure that? Every protocol emits a different kind of data, but every blockchain cannot read that data, right? Blockchain needs deterministic transactions. Blockchains need data structured in the right format so that the smart contracts can take decisions. But IoT devices don't send structured data. Hence, we specifically need to build an integration layer so your IoT devices don't directly send the data to the blockchain, but those devices send the data to that integration layer, and that integration layer then further emits the data to the blockchain. If you keep on changing devices, you are just getting more and more workload. You are overloading that integration layer by writing different logics, and at one point of time, it would be a lot. So no IoT device can directly communicate with blockchain. You need to establish a central layer, and that central layer will structure the data that basis on what needs to be fed to the blockchain, basis on what blockchain wants to listen, based on what the smart contracts wants to listen, wants to feed in, wants to consume, and then you emit the data. There cannot be a direct interaction. We don't have direct interaction tool available right now. Performance, not scalability. With performance, generally people think about scalability of blockchain. Blockchains have got scalability challenge, but now the era in which we are right now, I don't see scalability as a problem. I don't see vertical scaling or horizontal scaling as a problem, any of them. Earlier, if I have to talk about what was there in the industry 2 years back, 3 years back, four and a half years back, when I started my blockchain journey, there were so many issues. We used to see the Bitcoin core code, that how it has been designed, and there was no solution ahead. But now when you see the industry, it has made a mark. When we talk about performance, it's not scalability right now, but it's actually the throughput. With let's say 10,000 devices or 20,000 devices in a food supply chain industry continuously emitting data, can your blockchains take that much data? Can your blockchains deliver that much output? Will that be an issue? 20,000 transactions coming in at the same time? No. We need to set up a separate queuing mechanism. And that queuing mechanism is going to put all those transactions one after the other, so based on what your blockchains can tolerate in terms of incoming throughput and also in terms of outgoing throughput. When we query the ledger, how many queries we make to the ledger? Right? And plus, of course, to deal with the IoT devices, we need a mesh or a decentralized network for the IoT devices. Data connectivity across country or continents, we cannot deny this fact that the data connectivity, the 4G connectivity, the 5G connectivity, which is not in place right now, but 4G, 3G, WCDMA connectivity right now is not that efficient what we need. This is not something, a problem with blockchain and IoT. Sorry, someone saying something? Okay. So this is not a problem with blockchain and IoT combination. This problem is an overall problem of the infrastructure, but that is the infrastructure that we consume. That is the infrastructure that we consume. That's the reason this is not marked completely in orangish, but a mild green, because we do have a solution to an extent, but we also don't have a solution. So we are midway. High costing for migration to the proposed network and incompatible protocols. When we talk about IoT, we talk about challenges in the system. Listening to those challenges, we further produce one challenge, that how are we going to, how much does it cost? So if today I'm an investor, okay, and someone approaches me with this idea, let's say I don't have enough knowledge about blockchain and IoT, and someone is trying to teach me about it. Now as a layman, I'm going to think, first, I have to deal with these many challenges. And secondly, you tell me that to invest into the system, to the kind of storage we need, to the number of devices we need, I need to spend a big amount. You're not paying any licenses for blockchains because most of the blockchains are open source, but you still need to invest in every device, and every good device, every good chip that you are investing in. So out of all of this, we have challenges, and we are trying to build workarounds for those challenges. Plus, you are asking me to invest this much. And secondly, incompatible protocols. As discussed earlier, different IoT devices have got different protocols, the way they emit messages, which is not in line. There is no standard in the industry. The lack of standards in the industry is basically which is killing it, and which is acting as a big stopper for us to witness those applications, those right applications. What do we aim to build? Maintaining transparency and privacy at the same time. We almost everywhere on the internet, when you search, you will see this as a challenge, but this is no more a challenge. I just wanted to check on that, because now with different blockchain platforms, we have got different ways to handle privacy. Corda uses a direct messaging. It doesn't use broadcasting. Okay, it uses point-to-point messaging protocol. It doesn't use the message broadcasting. The way in blockchain says every node has got the same data, but you still have ways to protect your data. For example, the private data feature. If I have to keep IoT out of the system, and let's say we are building an application where I'm selling apples, and I have got two buyers. I've got those two buyers on the same blockchain network. Now, when I am selling apples, let's say I'm selling apples for 10 rupee, for 50 rupees a kg to buyer one, and I'm selling the same set of apples for 80 rupees per kg to buyer two, which is very normal in a business, right? You always don't have you don't have the same rates for everyone. It's pure business. But because of blockchain, buyer one will be able to see that I am selling it for 80 for buyer two, and buyer two will be able to see that I am selling it for 50 to buyer one, which is going to create a business conflict. Buyer two is going to come and say, hey, Pranav, you are selling 30 rupees less to buyer to this person. How can you do that? That means I cannot use blockchain. But no, there are ways how I can protect this piece of information on the same ledger. On the same ledger. These features were built to make blockchains GDPR compliant. When the GDPR rules were launched in the Schengen area, that's when a rule was launched, right to forget data. If today I leave the network, that means my data should not be in public. I'm going to take away all my data along with me. So we have a lot of privacy features across different platforms right now, which are available, and we can architect different solutions using those features so that we have transparency, we have data integrity, and we have privacy maintained at the same time. At the same time. For data integrity, we use hashes, we use different algorithms to check the data. We store the data in encrypted forms. Across blockchains, we have asymmetric cryptography, which has been implemented. But in order to store your data in any of the cloud services, you can use symmetric encryption as well. If your file sizes are bigger, then you should go for symmetric encryptions. And plus, you have transparency and privacy at the same time. It's just that how we design, how we put different components all together. That's the only thing. Right? So these are the few challenges. The major challenges, I would say there would be many, but these are the major challenges when it comes to blockchain and IoT together. The benefits are a lot, but again, everything has got challenges because these are all emerging technologies. No technology is mature to an extent that we have standards around the industry. There are no regulations. There are no governance models, but we are slowly building. We have just started with it. We are slowly building those models. Right? Perfect. So, any questions, thoughts, comments?
Any queries, participants?
No questions? Everything's clear?
Dear
Anyone?
participants, you can ask any questions.
Anyone wants to, I mean, I would be glad to hear if you have something interesting in mind which you want to share with us, and something which we are not aware of across this industry. That'll be great. I mean, it's always welcome.
So the participants are giving very good feedback in the chat box. I think they don't have any questions. Thank you very much for accepting our invitation, and the session was very informative, sir. Thank you so much for taking it in a very elaborative manner. Thank you so much, sir.
No worries, sir. Thank you. It was my pleasure to be out here. Yep, it's always fun. Thank you for your questions. Thank you for whatever you ask, and we always learn from these questions. So thank you so much. Take care,
Thank you,
everyone.
sir.
God bless.
Thank you. Bye.
Thank you, sir.
Thank you very much. Bye bye.
Thank you. Bye bye.
Thank you, sir. Dear participant, the feedback link has been posted here in the chat box, and you can fill it.